Good evening everyone, good evening. I welcome you all again to NEET Elite after so long. I hope all of you are doing wonderful, my dear elites. Just quickly, let me know in the chats if I'm perfectly audible and visible to everyone. Hello Ashwarya, hi Hitesh, hi Ishpreet. Hello Aisha, hello Harsh, hello Fazan, hello Prashant. Hello Naveed, hello Akash, welcome back. Hello Akhila, hi Darshini. Hello Sana. Welcome back people, welcome back again to your NEET Elite. Just quickly, give me some green signal from the chat so that I'll get to know that I'm audible and visible to every one of you. Yes, exactly, I'm meeting you after so long, right? I know I'm meeting you after so long, and I'm sure you guys are going to be super duper excited about this particular session. So am I. I'm doing good, my dear people. Thank you. I'm doing good. Ashwarya, I'm better than before. Thank you. Thank you, Nitarshan. Thank you so much. So people, as you all must be knowing, tonight we are going to start the IUPAC nomenclature, right? Well, majority of the students wanted me to take one particular session on this IUPAC nomenclature. So I came up with this particular session in which I'll be exactly letting you know how to name different organic compounds, right? Well, I've planned two particular sessions for this IUPAC nomenclature, and in just two sessions, we are going to finish this IUPAC nomenclature from exact scratch, right? You just need to follow these two sessions which I'll be taking on this particular channel. I'm sure you can name any organic compound, right, after watching these two particular sessions. Perfect. So before starting the session, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. So people, my name is Wassim Sir and I'm your chemistry master teacher writer on this NEET Elite channel, yeah? Well, the ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this NEET Elite channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, okay? Sir, when will be the next session on solid state? Solid state will be after 2 days, right? After 2 days, I'll be taking a session on solid state, all right? So people, you can let me know in the chats if you all are super duper excited about this particular session. Let me know quickly in the chats, my dear elites, yeah? Let me know quickly in the chats if all of you are super duper excited about this particular session as well. Let me know fast, let me know fast. Perfect guys, perfect, wonderful. So I will be exactly starting from the scratch, right? And in the tonight's session, what we'll be talking about exactly, I'll show you how to name alkanes, how to write the IUPAC name for alkenes, how to write the IUPAC name for alkynes, right? Then we'll be talking about the cyclic compounds as well. In this session, in the tonight's session only, I'll be letting you know how to give the names to the cyclic compounds and as well as Spiro compounds as well. So all these things I'll be covering in the tonight's session right from the basics, okay? So as you all must be knowing, there are certain rules which you need to follow in order to name different organic compounds. And the first and the basic rule, which I'm sure every one of you would be knowing, that in the molecule we are supposed to get the longest possible chain, right? That's the first and basic rule when you try to name any organic compound. We are supposed to select the longest possible chain. That is the first rule. For example, these are few molecules which I've taken into consideration, right? Let's exactly have a look how to find the longest possible chain in these molecules which I've taken over here. Exactly from the scratch I'm starting, my dear people. Okay, exactly from the basics. So first thing, if you have a look on the first molecule, right? We are supposed to select the longest possible chain, right? See guys, have a look exactly. This can be one of the chains. This can be one of the chains, right? This can be one of the chains. And this chain which I've selected over here, how many carbon atoms it contains exactly? 1, 2, 3, 4, 5 and 6. So this particular chain, it contains 6 carbon atoms, right? Okay, this particular chain, it contains 6 carbon atoms. Now similarly, there is one more way by means of which I can select one more chain. This is one more chain we can select over here, right? This is one more chain we can select. Now let's count the number of carbon atoms in this particular chain. This is carbon number 1, 2, 3, 4, 5, 6, 7. So in this particular chain, you have got some 7 carbon atoms. What the rule exactly says? Select the longest possible chain. So can I say this is going to be my longest possible chain in this particular compound over here? As simple as that, right? This is my longest possible chain. Similarly, if you look at the second compound, if you look at the second molecule, in this molecule, I'm again supposed to select the longest possible chain, right? I'm not telling you how to name the compounds right now. Just let me give you some few rules, then I'll be giving you a lot of examples, a lot of questions by means of which you can master this IUPAC nomenclature, right? So people, what is going to be the longest possible chain over here? Well, I'm sure you all can easily identify it. This one is going to be basically the longest possible carbon chain in this particular compound. So this is going to be my parent chain, longest possible chain over here. As this chain, it contains 1, 2, 3, 4, 5, 6, 7, 8 and 9. It contains 9 carbon atoms. Yeah. If you look at the next one, we have got many ways of selecting the chains, but I'm supposed to select the longest possible chain, right? I'm supposed to select the longest possible chain. See guys, this can be one of the chains which I can select, and this chain will be containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It just contains 10 carbon atoms. This chain contains 10 carbon atoms, right? So if you'll have a look on one more carbon chain which I'm selecting, let's say this is the carbon chain which I'm selecting over here. Let's say this is this red colored one. This is the carbon chain which I'm selecting over here. So this carbon chain which I'm denoting with the red color, let's exactly count how many carbons are there in this particular chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in the second one which I'm denoting with red color, it contains 11 carbon atoms. So this is going to be my longest carbon chain in this particular molecule, right? So the first rule says select the longest possible chain in the molecule, and you can easily select the longest possible chain. I'm sure about that, right? Now guys, understand and remember. I want you guys to remember all these things one by one. Okay, there's a statement mentioned over here. If more carbon chains are multiple in number, then select the chain with maximum branches. What it exactly means. Have a look properly how we can understand this particular statement. I've taken just 2 different molecules over here, right? We are supposed to select the longest possible chain, right? If you look at this particular molecule, my dear people, this is one of the chains which I can select, which can be the longest possible chain. It contains 1, 2, 3, 4, 5, 6 carbon atoms, right? It contains 6 carbon atoms, this chain. Okay. Now similarly, I have drawn the same molecule again on this side, right? I've drawn the same molecule on this particular side, right? And in this particular side, I'm going to select this chain. This is the chain which I'm selecting over here. Right? This is the chain which I'm particularly selecting. Or let me not select this one. Let me just select this one. This is the chain which I'm selecting over here. Right? So look at this particular chain. How many carbon atoms this chain contains? 1, 2, 3, 4, 5, 6. Again, this chain contains 6 carbon atoms. Now, which one do I need to select over here? See guys, if you look at this particular chain, it just contains one substituent. It just contains one branch. Right? And this particular chain, how many branches it contains? This is one branch. This is one more branch, right? It contains 2 branches, right? See, the chains which you have selected, both the chains contain same number of atoms, right? So you need to select that chain which contains more branches. So which chain among the 2 contains more branches? It is the second chain. So this is going to be the chain which I'm selecting over here. I'm sure it's clear to everyone. Yeah, the second one. Similarly, let's have a look on this particular molecule. Right? I need to select the longest possible chain, right? See guys, this is the chain which I'm selecting over here, right? How many carbon atoms it contains? This is 1, 2, 3, 4, 5, 6, 7, 8. It contains 8 carbon atoms, right? 8 carbon atoms. And at the same time, if I ask you how many branches are there in this particular chain, this is one branch, this is one more branch. So there are 2 branches as well. there are 2 branches in this particular chain which I'm selecting over here, right? The same molecule I've drawn over here. The same molecule I've drawn over here. Now people, what I need to do, I will be selecting this as the carbon, this as the chain over here. Let me select this as the chain. Let me select this as the chain. See first of all, how many carbon atoms are there in this particular chain? Calculate them. 1, 2, 3, 4, 5, 6, 7, 8, right? There are again 8 carbon atoms which are there in this particular chain, right? If I ask you how many branches are there in this particular chain, this is one of the branch, this is one more branch, this is one more branch, this is one more branch. So how many branches it has? 1, 2, 3, 4. It has got 4 branches, right? I've selected 2 chains, right? Both have got same number of carbon atoms. Both the chains which I've selected, they have got same number of carbon atoms. So which one to select? Which one is going to be our chain, right? The one containing more branches. So this one is the one which I'll be giving the priority. As simple as that, right people? As simple as that. I'm sure this rule is clear to everyone. Okay, so select, the first rule says select the longest possible chain, right? Okay, and I'm sure this rule is again clear to you. If the longest chain contains, if there are 2 or more longest chains which you are selecting, then you'll be selecting that particular chain among the 2 which contains more number of branches. As simple as that. Perfect. Is it clear till here? Let me know in the chats. Let me know in the chats, my dear elites, if it's clear till here. Let me know quickly in the chats if it's clear till here. Then only I'll be moving on to one more rule. Basic one. Fearless Gaming, I'm doing good, my dear. I'm doing good, thank you. Perfect, guys. Perfect, perfect. Let's move on. Let's move on. Now the rule number 2. The rule 2, what it says exactly. The rule 2 says, first locant should get minimum number. Second rule says, first locant should get minimum number. What it means exactly. Have a look. First thing, I will be selecting the chain. This is the chain which I've selected. This is the chain which I've selected over here. This is the longest possible chain which I've selected. Number 1. Number 2. Now after selecting the longest possible chain, I need to start numbering this chain. Right? I need to start giving numbers to the atoms in this chain over here. Now I've got 2 options. Either to start the numbering from left or to start the numbering from right. So first thing, if I start the numbering from left, this carbon will be getting carbon number 1. This is getting the number 2. This is getting number 3. This is getting number 4. This is getting number 5. So on starting from left to right, this is the way you're going to number them, right? Now people, if I start the numbering from right to left, then this carbon is going to get the carbon number 1, this carbon is going to get the number 2, this will get number 3, this will get number 4, this will get number 5, right? This is the numbering which I've started from right to left, correct? As simple as that. Now which one should I select? The basic thing, right? Have a look. If I give the numbering from left to right, then at carbon number 4, you are getting the substituent. From left to right, at carbon number 4, you are getting the substituent. When you start the numbering from left to right, at carbon number 4, you are getting the substituent. Now people, if you start the numbering from right to left, at carbon number 2, you are getting the substituent, right? From right to left. When you start the numbering from right to left, at carbon number 2, you are getting the substituent, right? So where is the locant minimum? 2 is less than that of 4, right? So you have to follow the first locant rule. First locant should get the minimum number. So first locant over here is 2 and this is minimum among the 2, right? So from where you're going to start the numbering? From left to right or right to left? It's going to be right to left. The first locant should be minimum, right? When you start numbering from right to left, the first locant is getting number 2. When you start the numbering from left to right, the first locant is getting the number 4. Which one is the least value among the 2? This one is the least value among the 2. So you're going to give priority to this one, right? So you will start numbering from that particular direction in which the first locant gets the minimum number. As simple as that. Similarly, you have got this particular chain as well. Let's have a look exactly. See, after selecting the longest possible chain, right, which I'm sure you would have already done that. Now I've got 2 ways to number. 1, 2, 3, 4, 5, 6, 7 from left to right. Similarly, from right to left. From right to left, I can do the same. 1, 2, 3, 4, 5, 6, 7. When I start the numbering from left to right, at carbon number 5, you are getting the substituent. You are getting the substituent, right? When I start the numbering from left to right. left to right. And when I start the numbering from right to left, at what position you are getting the locant? You are getting the locant at carbon number 3, right? As per the rule, first locant should get the minimum number. First locant should get the minimum number, right? So first locant is getting the minimum number. So you'll be starting the numbering from right to left, and this is going to be the actual numbering over here. From right to left, 1, 2, 3, 4, 5, 6. So this is going to be the actual numbering. This one. Perfect, as simple as that. Yes, people. Similarly, if you look at the next one, again the same thing which you're going to do. First, I'll start the numbering from here. 1, 2, 3. This is 4. This is 5. This is 6. This is 7. This is one type of numbering which I can give to the parent chain, right? Now, people, you can give this sort of numbering as well from right to left. 1, 2, 3, 4. This is 5. This is 6. This is 7, right? When I do the numbering from left to right, the first locant is coming at carbon number 4. The second locant is coming at carbon number 6. I'm right now talking about the first locant, not the second locant, right? And when I start the numbering from right to left, my first locant is coming at carbon number 2, right? Follow the lowest locant rule. So start the numbering from right to left. So this is going to be the actual numbering which you can provide over here. I'm sure it is clear to everyone, right, people? Let me know fast. Yes, Benedict, it's going to be helpful, absolutely. Let me know in the chats if this rule is again clear to you. The lowest locant rule. The first locant should always get the minimum number. In that manner, you're going to do the numbering. Yeah? First locant always should get the minimum number. Moving ahead. Now the case can exist like this as well. If first locant is same, right, then go for the lowest sum rule. What it means exactly? If first locant is same, go for the lowest sum rule. See, this is the molecule which I have. I've got two ways to start the numbering. From here, 1, 2, this is 3, 4, 5, 6, and 7. This is one of the way I can do the numbering to the parent chain, right? So I've done the numbering from left to right in this particular case. Now, I've got one more way to give the numbering as well. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So from right to left, you can start the numbering in this way, correct? Now, if you are giving the numbering from left to right, so at carbon number 2, the first locant, right? At carbon number 2, you have got the substituent. At carbon number 2, right? And then at carbon number 3, you are getting one more substituent. And then at carbon number 6, you are getting one more substituent, right? When you start the numbering from left to right, these are the positions where your substituents are, basically, when you start giving numbering from left to right. And when you start giving numbering from right to left, at what all positions do we have these substituents? At carbon number 2, absolutely, right? And then at carbon number, this 5, yeah? And then at carbon number 5, and then carbon number 6, right? Okay. Now see, exactly see, is the first locant same in both the directions? First locant is same, right? When the first locant is same, then you are going to follow the lowest sum rule. Just add these three terms over here. So 6 plus 3, 9, 9 plus 2, 11. So the sum of these locants is coming out to be 11. And sum of these locants, 6, 5, 11 to 13, right? Sum of these locants is coming out to be 13. You are going to follow the lowest sum rule. Where is the sum coming out to be lowest for these locants? This is the lowest sum for the locants. So this is going to be the actual numbering of the carbon chain. As simple as that. So you'll be starting giving numbering from left to right. Perfect? Yeah? I'm sure it's clear. So do remember the rule number 2. If the first locant is same, then go for the lowest sum rule. This is the important rule which you're going to remember from now onwards. Perfect? Moving on, if this is clear, then I'll move on to one more case. Okay. Have a look on this particular case, guys. Understand it properly, because this might confuse you afterwards. If the first locant and the lowest sum rule are same, right? Now, if the first locant is same and at the same time the lowest sum rule is also same, the lowest sum is also same, then go for the alphabetical order. What it means exactly? Let's have a look properly. First thing, I'll be giving the numbering from left to right in this particular case, and right here I'll be giving the numbering from right to left. Okay? So I've selected already the longest possible chain. This is the longest possible chain which I've selected, right? So let's call this as 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7, right? The first locant is 3. At carbon number 3, you have got the first substituent. At carbon number 5, you have got one more substituent. At carbon number 5, you have got one more substituent, right? So there are basically 2 substituents in this molecule, in this parent chain. When I select this as the parent chain, there are 2 substituents at carbon number 3 and at carbon number 5. Okay, now what I'll be doing, I'll be starting the numbering from here. It's 1, this is 2, this is 3, 4, 5, 6 and 7, right? So basically at carbon number 3, you're getting the substituent, right? And at carbon number 5, you're getting the substituent, right? So when I start the numbering from left to right, or if I start the numbering from right to left, the first locant is coming out to be same in both the ways. The first locant is coming out to be same. This is 3, right? When the first locant is same, then go for the lowest sum rule. 5 plus 3 comes out to be 8. 5 plus 3 comes out to be 8. Now the sum rule is also coming out to be same. The sum of the locants is also coming out to be same. Now how do I select the chain? Then go for the alphabetical order. Go for the alphabetical order. See guys, which substituent this is? Which substituent this is? This is basically ethyl. This is basically ethyl, right? This is CH2 and this is CH3. This is ethyl, right? Which substituent this is? This is methyl. Perfect. Follow the alphabetical order. The first letter over here is M and the first letter over here is E, right? So follow the alphabetical order. Can I say E comes before M? If E comes before M, I'll be giving priority to this ethyl group only. I'll make sure the ethyl group, it gets the minimum number. And in which way ethyl group is getting the minimum number? In which way ethyl group is getting the minimum number? This is the way in which ethyl group is getting minimum number. So I'll be starting the numbering from right to left. This is my correct way, right? Yeah? I'm sure it's clear to everyone. People, you got it? Let me know quickly in the chats if you got this particular rule as well. Right? Let me quickly know in the chats if you got this particular rule as well. So do remember, if the first locant is same, then go for the lowest sum rule. If the sum rule is also coming out to be same, you're not able to decide by means of sum rule, then you're going to follow the alphabetical order. That's all. Perfect. Moving on to one more. This is something which every one of you, I'm sure, knows, right? When we try to write the IUPAC name of any compound, it has got many parts in it, right? Word root, prefix, primary suffix, and secondary suffix, right? Okay, what this word root exactly is all about, what this primary suffix is, I'll be giving you examples and you'll be getting all these things cleared with time, right? This is something which every one of you would be knowing. If in the main chain there is one carbon atom, so you're going to use the word root as meth. Similarly, 2 carbon atoms, eth, prop, bute, pent, hex, hept, right? Oct, non, dec, undec, dodec, tridec, tetradec, etc., etc. This is something which every one of you would be knowing. I'm not going to talk about this particular thing, right? This is something which you study in your class 10th as well. Perfect. And carbon number, if there are 15 carbon atoms in the main chain, you use the term pentadec. 19 carbon atoms, a nonadec, right? 20 carbon atoms, ICOS, okay? Perfect. This is something which you all must be knowing, right? So, what we shall be doing now, we shall be exactly saying the names of simplest molecules first, right? Let's try to give names to the simple molecules over here. These are the 3 molecules which I've selected. I would want you guys to name them one by one, okay? So this is the first molecule, guys. So first thing, whatever rules we have selected till now, I'm going to use all the rules. The first rule says select the longest possible chain, and this is the longest possible chain which we have selected, right? Now start giving the numbering. You will be giving numbering in such a way by following the lowest locant, sum rule, and then alphabetical order. And over here, if I start numbering from right to left, 1, 2, 3, 4. This is going to be the actual numbering of this, right? Perfect. If you look at the second molecule, start giving numbering. This is 1, this is 2, this is 3, this is 4, 5, 6, right? You have given the numbering over here as well. Perfect, people. So let's try to name the first one. At carbon number 2, you have got the methyl attached. You have got CH3 attached at carbon number 2. Okay, so what it's simply going to be, at carbon number 2, then you'll be drawing a dash over here, hyphen over here, right? 2, then I'll be writing methyl. At carbon number 2, you have got the methyl attached. 2 methyl, right? The main chain contains 4 carbon atoms. It's simply going to be bute, and there is a single bond everywhere, so it's going to be the name of the compound, 2-methyl butane. right? As simple as that. These are the simple molecules from where I'm starting. If you look at the second one, at carbon number 2, this is basically your CH3 attached, right? This is the methyl group attached at carbon number 2. So I'll be naming it as 2-methyl again. This is going to be 2-methyl, and the main chain contains 6 carbon atoms. So word root is going to be hex, and then there is a single bond everywhere. I'll be using ane over here at the end, right? This is the name of the compound. Perfect. Now if you look at this particular one, have a look exactly. Guys. So let's have a look on the longest possible chain first of all. This is the longest possible chain which we can select, right? Now I have to start giving the numbering. 1, 2, 3, 4, 5 and 6, right? Okay. If you start giving the numbering from left to right or from right to left, both are going to be the same, right? Both are going to be the same. Why is that? Let me show it to you. You should not get confused or something. If I call this as carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. This is one way to to give the numbering from left to right. Yeah, there is one more way. Just do it from right to left. 1, 2, 3, 4, 5 and 6. If I start the numbering from left to right, then the first locant is coming at carbon number 2, right? And the second one is coming at 5. Perfect. Right, people? Similarly, if you start the numbering from right to left, the first locant is coming at 2 and second locant is coming at 5, right? And both the substituents are same. So if you start the numbering from left to right or right to left, it does not make any difference over here, right? It does not make any difference over here. So let me give the numbering from here. 1, 2, this is 3, this is 4, this is 5, this is 6, right? Now at carbon number 2, you have got methyl attached. At carbon number 5, you have got methyl attached. So you have got 2 methyl groups attached, right? You have got 2 methyl groups attached, which are acting as the substituents over here. So it's going to be at carbon number 2 and at carbon number 5. So 2, 5. Between two numbers, you always put a comma. Right? Do remember. Between a number and the letter, you always put a hyphen. Between two numbers, you always put a comma. Between a number and the letter, you always put a dash, a hyphen. Yeah? Right, people? Now start giving the name. At carbon number 2 and at carbon number 5, you have got methyl groups attached. So how many methyl groups are there? 2 methyl. So 2, 5, I'll be writing dimethyl. Right? Dimethyl. Then in the main chain, how many carbon atoms do we have? 1, 2, 3, 4, 5, 6. 6 carbon atoms. So word root is going to be hex, right? And then there's a single bond everywhere. So this is going to be the name of the compound. Starting with these basic examples, I'm sure all the rules, whatever we have discussed till now, it's clear to everyone. Perfect. Voice is cracking. People, is the voice cracking? Is the voice cracking? Just let me know in the chats. Then who is this nonsense guy who's saying voice is cracking? You can get the hell out of this class. Don't try to disturb. Okay, moving on. These are few more molecules, my dear people. Let's try to name them. Okay, let's try to name them. Let's try to name them. Have a look. First thing, I will be selecting the longest possible chain. This is the longest possible chain which I've selected, right? Now, I'll be starting the numbering either from left to right or from right to left, considering the lowest locant rule. The lowest locant. The first locant should get the minimum number, right? And then followed by the lowest sum, followed by the alphabetical order. Yeah? Right? So, I'll be starting the numbering from here. This 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay? So people, at carbon number 2, you have got methyl. At carbon number 4, you have got ethyl. So this is basically your methyl group, right? This is basically your ethyl group which is attached. Okay? At carbon number 2, you have got methyl. At carbon number 4, you have got ethyl. Now people, still see the first letters. This is M, this is E. You guys know, as per alphabetical order, E comes first, then comes your M. So first thing, I will be writing 4. At carbon number 4, you have got ethyl. It's going to be 4 ethyl, right? At carbon number 2, you have got methyl, right? At carbon number 2, you have got methyl. So it's going to be 4 ethyl, 2 methyl. Then the parent chain contains 6 carbon atoms. So it's going to be hex and single bond everywhere. So it's going to be hexane, right? Perfect. I'm sure it's clear. Similarly, guys, have a look on this particular molecule. Start the numbering. I'll be starting from here. 1, 2, this is 3, this is 4, this is 5, this is 6, this is 7. Perfect. selected the carbon chain, done the numbering as well. So at carbon number 2, there is methyl. At carbon number 3, there is methyl. At carbon number 4, there is ethyl, right? So methyl or ethyl, alphabetical order. E comes first. So I'll be first of all writing 4-ethyl. 4-ethyl, right? Then we have got at carbon number 2 and at carbon number 3, we have got 2 methyl groups, right? So 2, 3, then I'll be writing dimethyl. Right? In the parent chain, you have got some 7 carbon atoms, so it's going to be heptane. This is the name of the molecule, right, people? As simple as that. Now, if you look at the next one, just have a look on the next one. So let me select from here. It's carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. 1, 2, 3, 4, 5, 6. Okay. This is the chain which we have selected, right? And you have done the numbering as well. Let's try to name it now. And I'm sure you can easily name it now. At carbon number 3, there is ethyl group attached. At carbon number 4, there is ethyl group attached. So I'll be writing 3, 4. 3, 4, right? 3, 4. It's going to be diethyl. 3, 4, diethyl. In the parent chain, there are 6 carbons. So it's going to be hexane. Right? Everywhere there is single bond. So this is going to be the name of this molecule. So let's take few more. Let's talk about few more molecules. Now the point is, whatever substituents were there in the parent chain, right? Whatever substituents were basically attached to the parent chain, all those substituents were simple substituents, methyl, ethyl, propyl, etc., etc. Now the point is, if the substituent is the complex one, how do we name it at that point of time? Let's have a look. For example, this is one of the molecule which I've taken, right? So let me first of all select the parent chain and then let me number them. 1, 2, 3, 4, 1, 2, 3, 4. Choice is all yours. So I'll be starting the numbering from here. 1, 2, this is 3, this is 4, this is 5, this is 6, this is 7, right? As you can see, till now we used to have only the simple substituents, but right now there is a complex substituent. This is the complex substituent over here, right? So this complex substituent, I'll be making it as the side chain. I'll be starting the numbering in the side chain as well. Let me call this as carbon number 2. Let me call this as carbon number 3. So how do I name it now? My actual chain, this is my actual chain which we have selected, right? So in the actual chain at carbon number 4 there is a substituent, right? In the actual chain at carbon number 4 there is a substituent. Now at the carbon number 4 there is a substituent. Is the substituent simple or complex? It's some complex, right? Okay. And in the side chain which you can see, at carbon number 1 there is methyl, right? So I'm writing 1 methyl. Then you have got 2 carbons in the side chain over here. So I'll be writing 1 methyl and then I'll be writing ethyl. So it's going to be 1 methyl, ethyl. Then in the parent chain you have got 7 carbon atoms. So I'll be directly write hept and there is a single bond everywhere. So it's going to be heptane. As simple as that. Yes, Twinkle, you can do that as well. No issues. Perfect. Okay. Moving on to one more. If you will be having 2 or more same complex substituents, what do we do at that point of time? If you'll be having 2 or more same complex substituents, do remember when you'll be having 2 or more same complex substituents, right? Then for 2 same complex substituents, you use the term bis. For 3 same complex substituents, you use the term tris. For 4 same complex substituents, you use the term tetrakis, right? Similarly, for 5 same complex substituents, you use the term pentakis. These are the terminologies which you need to remember, okay? Now we will have a look. There are 2 substituents basically, and both the substituents are complex substituents, right? Let me start the numbering first of all. This is carbon number 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, and 9. Yeah? As simple as that. This is the chain which you have selected. So at carbon number 4 and carbon number 5, there are basically what? At carbon number 4 and at carbon number 5, there are complex substituents, okay? So at both the complex substituents are same, right? There are 2 same complex substituents. So should I be using the term bis? Absolutely, I'll be using the term bis. right? I'll be using the term bis. Right, people? Then, few minutes back only I told you how to write the name of these complex substituents. I mentioned it over here, right? See, at carbon number 4 and at carbon number 5. 4, 5 bis. 4, 5 bis, right? Start the numbering in this side chain. At carbon number 1, there is methyl. So it's going to be 1 methyl ethyl. 1 methyl ethyl. Then in the main chain, you have got 9 carbon atoms. So it's going to be non and then ane at the end, right? I'm sure these type of molecules you can easily do from now onwards, right? If there will be 2 or more than 2 complex substituents, I'm sure you can easily name it from now onwards. Perfect, guys? Perfect. Let's have a look on few more rules now. Now comes one more rule. One simple rule, right? For alkenes basically. This is something which every one of you would be knowing, I'm sure. Double bonded carbon receives the lowest number. Double bonded carbon receives the lowest number. Maximum multiple bonds to be included in the main chain. These are 2 important things which you need to take into consideration. You can easily do it, right? The first one says, just a second. The first one says double bonded carbon receives the lowest number. The double bonded carbon, it should receive the lowest number, and at the same time, maximum multiple bonds are supposed to be in the main chain, right? So the first rule says the double bonded carbon, right? It must get the lowest number. So this is how you are going to number them. 1, 2, 3, 4, this is 5, this is 6, this is 7. So you'll be simply calling it as hept, right? And then you have got at carbon number 2, there is a double bond, and so it's going to be hept 2ene, as simple as that. Now we have got one more over here. This is one more. The first rule says the double bonded carbon should receive the lowest number, and at the same time maximum multiple bonds to be included. If maximum multiple bonds are to be included, then this has to be the parent chain. This has to be the parent chain. Now you have to start giving the numbering, right? If I start numbering from here, 1, 2, at carbon number 2 there is a double bond. If I start numbering from here, 1, 2, at carbon number 1 you have got the double bond, right? So I'll be starting the numbering from here. I'll be starting numbering from here. Let me call this as carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Perfect. So first thing, at carbon number 3, there is the methyl group attached. There is a substituent methyl. So I'll be calling it as 3. Let me call this as methyl. Right? 3 methyl. 3 methyl. Right? Now, in the main chain, you have got 7 carbon atoms. So let me call it as hept. Yes, let me call it as hept. Now do remember, if there will be 2 or more than 2 pi bonds, if there will be 2 or let me call it like this, if there will be 2 or more than 2 double bonds or 2 or more than 2 triple bonds in the parent chain, then after the word root you use the A over here. So you'll be writing hepta, right? You'll be writing hepta. It's not going to be hept, it's going to be hepta. When there will be 2 or more than 2 double bonds in the parent chain, or there will be 2 or more than 2 triple bonds in the parent chain, then after the word root you use the letter A. So it's going to be hepta, right? And after hepta, at carbon number 1, at carbon number 1 and at carbon number 5, there are the double bonds. So it's going to be 1, 5 and diene. This is going to be the name of the compound, right? As simple as that. If you look at this particular case, have a look. 1, 2, 3, 4 and 5. So it's going to be pent. Should I write pent or penta? Should I write pent or penta? Absolutely guys, it's going to be penta. Because in the main chain, there are 2 double bonds, right? So I'll be writing penta over here. Then at carbon number 1 and at carbon number 3, 1, 3, there is diene basically, right? This is the name of the compound. Yeah? I'm sure this is clear to everyone. Moving on to a few more guys. Moving on to a few more. Let's have a look and let's try to name all these compounds over here, and I'm sure you can easily kill them now, right? These are the basic alkenes which I've taken first of all, okay? Let me give the numbering first of all. Numbering, I'm sure every one of you can do it. 1, 2, 3, this is 4, this is 5, this is 6, this is 7, right? So I'll be using the word root as hept. Should I be using just hept or hepta? There are 3 double bonds in the parent chain, so I'll be using the term hepta, right? At carbon number 1, at carbon number 3 and at carbon number 5. Yes, you have got 3 double bonds. So I'll be using tri and then I'll be writing ene. Hepta 1, 3, 5 triene. Perfect. If you look at this one, as I told you, double bonded carbon should get the lowest number, number 1. Right? Multiple bonds must be present in the parent chain. They should be present in the parent chain, right? So let me give the numbering. If I start numbering from here, let me call this as carbon number 1, this is 2, this is 3, this is 4, this is 5, because the multiple bonds are to be supposed in the parent chain, right? Okay. So people, what is going to be the name of this particular compound? At carbon number 3, what is the group attached? This is CH3, this is CH2, this is CH2. So it is basically the propyl group which is attached. It is basically the propyl group which is attached. So I'll be writing 3, then I'll be writing propyl, right? It's going to be 3 propyl, perfect. In the main chain, there are 5 carbon atoms. So it's going to be pent. Should it be pent or penta? There are 2 double bonds in the main chain, so it's supposed to be penta, right? And at carbon number 1 and at carbon number 4, so it's going to be 1, 4, it's going to be diene. This is the name of the compound. As simple as that, right? Perfect, guys. Now, if you look at this particular one, multiple bonds are supposed to be in the parent chain, right? Let me call this as 1. Let me call this as 2. Let me call this as 3, 4, 5, 6. Yeah? So basically, if you can see, at carbon number 3, you are getting ethyl. At carbon number 4, you are getting methyl, right? You are getting methyl. By the way, you had 2 ways to select the chain. You either can start numbering from here, or you could have started numbering from top. 1, 2, 3, 4, right? 1, 2, 3, 4. If you start the numbering from top, then this carbon would have got number 3. This carbon at that point of time should have got number 4, right? But this is ethyl, this is methyl. E comes first. So this group should get the lowest number. So you should start the numbering from bottom to top, right? That's something which I told you in the beginning itself, right? So I've given the numbering. So what is going to be the name of the compound? At carbon number 3, this is the ethyl group attached. At carbon number 4, this is methyl. E, ethyl. M, methyl, right? So E comes first. So I'll be writing 3 ethyl. I'll be writing 3 ethyl, then 4 methyl, 3 ethyl, 4 methyl, right? In the main chain, there are 6 carbon atoms. It's going to be hex. Should it be hex or hexa? There are 2 double bonds, right? So it's going to be hexa, right? And then at carbon number 1 and at carbon number 5, 1, 5, it's going to be diene. Done, understood, right? I'm sure you can name all these compounds from now onwards. Simple. Moving on. Let's name these alkynes. Let's name these alkynes. Let's name these alkynes. So again, let me call this as 1, this is 2, this is 3, this is 4. Every one of you can solve this one. This is but 1, Y-N-E-ine, because this is a triple bond. You guys know it. Okay. Now, I've got 2 choices, to start the numbering from left or to start the numbering from right. I'll be following the first locant rule. The first locant should always get the minimum number. So let's call this as 1, let's call this as 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So the word root says it's going to be hept. But is it going to be hept or hepta? There are 2 triple bonds. So it's going to be hepta, right? It's going to be hepta. Then at carbon number 2 and at 4. At carbon number 2 and at 4, you are going to write di, then you are going to write Y-N-E-ine, right? This is going to be the name of the compound. Hepta 2,4-diene, right? Now, if you look at this particular case, my dear people, let me select the numbering from here. If this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Multiple bonds should be present in the parent chain, right? So what is going to be the name of this particular compound? Have a look. At carbon number 3, this is ethyl, right? At carbon number 3, this is the ethyl group attached, okay? Now, in the main chain, there are 7 carbon atoms, right? So it's going to be hept. Is it supposed to be hept or hepta? It's going to be hepta, absolutely, because there are 2 triple bonds in the main chain, right, people? Right? After hepta, at carbon number 1 and at 6, 1, 6, it's going to be di, then Y-N-E, because there's a triple bond, diene. Yeah? Absolutely, people. Perfectly done. I'm sure you can name all these compounds from now onwards. Now, let's talk about those compounds wherein there are pi bonds, there are double bonds as well as triple bonds. Till now, we have talked about only those compounds wherein there will be double bond or there will be triple bonds. We have not seen any compound which contains double as well as triple bond. Let's try to name those sort of compounds now. Okay, let's try to name those sort of compounds now. These are the rules which you are going to follow, and all the rules we have discussed. First locant should get the lowest number. If the first locant is same, then follow the sum rule. If the sum is also coming out to be same, then follow the alphabetical order. These are just the 3 rules which you need to remember, which you need to know. Okay, for example, let me take these 2 molecules first thing. Let me take these 2 molecules. I'll be starting the numbering from here. 1, 2, 3, 4 and 5. Why is that? Because the first locant should get the minimum number, right? If I start the numbering from left to right, the first locant is 1. If I start the numbering from right to left, the first locant comes out to be 2, right? So I'll be starting from left to right. That's it. Okay, now the main chain, it contains 5 carbon atoms, so it's going to be pent. It's going to be pent. Over here, you're not going to use penta because this is double, this is triple, right? If both are double or both are triple, then only you use A after the word root. But right here, you're not going to use the A after the word root. Okay, so it's going to be pent. Now, this is basically een, this is ein. This is een, this is ein. Follow the alphabetical order, E or Y. You'll be giving priority to E as per alphabetical order, right? So it's going to be pent, then comes 1, then comes een, then comes dash, then add carbon number 3, right? You've got Y and E. Perfect. People, I've just used En over here. I've not used Ene. Just a second. I've just used En over here. I've not used Ene, right? So basically, whenever after this en or ein, whenever a vowel starts, it's a vowel. Y is a vowel, right? At that point of time, this one gets dropped. This one gets dropped. Yeah? It's not Ene, right? Whenever after your ein or ein, for example, after your ein or ein, there is the vowel which starts just the next, right? At that point of time, you are supposed to drop this E over here. Do remember this one as well. So let's try to name them now. Okay, look at this particular case. Look at this particular case. Have a look. I've got 2 ways to number. If I start from here, 1, 2, 3, 4, 5. This is one of the way by means of which I can do the numbering, right? If I do the numbering from here, at carbon number 1, right? At carbon number 1 and at carbon number 4. 1, 3 and 4, right? I'm talking about the locants. 1, 3, because at 3 I've got this group attached. 1, 3 and 4. If I start the numbering from here, just a second. If I start the numbering from here, it's going to be 1, 2, this is 3, this is going to be 4, this is 5. Then at that point of time, what are going to be my locants? 1, this is again 3, right? And again 4, right? The locants are coming out to be same. The locants are coming out to be same. See, first locant is same. The sum rule, the sum of these locants is also the same. Now, what should I be doing? What should I be doing? I'll be following the alphabetical order. This is ein, this is ein. E comes first. E comes first. Ein, ein. E comes first. So I'll be starting the numbering from here. I'll be giving priority to the double bond. This 1, this 2, this is 3, this 4, this is 5. Right? So what is going to be the name of this particular compound? In the main chain, there are 5 carbon atoms. But at carbon number 3, what is the group attached? 1, 2, 3, 4. It is the butyl group attached at carbon number 3. So after 3, just the dash. It's going to be butyl. 3 butyl, right? In the main chain, there are 5 carbon atoms. So it's going to be pent. It's going to be pent, right? Pent, it's going to be 1. Then I'll be writing Ene basically, right? And after that at carbon number 4, you'll be writing Yne. But just have a look. Just after this E vowel started, so drop this E. You're not going to write this E. So the name of this particular compound is going to be 3-butyl pent 1-in-4-I, right? This is going to be the name of the compound. As simple as that. Moving on, and let's have a look on few more. Let's have a look on few more. I think we solved them, no? No, we didn't. Look at this particular case, guys. So should you start the numbering from left to right or right to left? Lowest, the first locant should get the minimum number. That's the first thing which you'll follow. So this is going to be 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8. So it comes out to be oct, right? Oct. So this is basically ein, this is een, right? So at carbon number 6, there is En, and at carbon number 1, there is Yne, right? This is the name of the compound. As simple as that. Same is the case in the next one. I'm sure you can easily solve this particular one, right? Start the numbering. So it's going to be hepta. It's going to be hepta because you have got 2 double bonds over here in the main chain. It's going to be hepta, right? At 1, just a second, guys. It's not 1, 6. Just a second. It's 1 and 3 over here. 1, 3. 1 and 3. 1, 3 diene, right? Then we have got at 6, it's going to be ein. Perfect. And this E over here has been dropped. Yeah, I'm sure you can solve this one. It's again simple. Let's move on to the cyclo compounds now, right? See, these are all the closed rings. Whenever you see the closed rings, you'll be calling them as the cyclic compounds, right? Okay, so this is the cyclo one, this is cyclo, this is cyclo. It is simple. This is basically your cyclopropane. This is your cyclopropane, right? This is your cyclo 1, 2, 3, 4. Perfect, 4 carbon atoms. So this is cyclobutane. This is going to be cyclobutane. You just add this cyclo in the beginning, that's all. What about this one? Over here you're going to do the numbering, right? Let's call this as carbon number 1. Let's call this as 2, 3, 4, 5. So 1, 2, it's going to be dimethyl. 1, 2, dimethyl. Then it's going to be cyclopentane, right? Cyclopentane. As simple as that, right? Right, people? Very simple one. Perfect. Now let's have a look on few more important examples, right? Simple ones we are doing. I'm sure you can easily solve them now. See, let's first of all give the numbering. Let's start from this carbon. 1, 2, 3, 4, 5. First locant should get the minimum number, right? That's why I started the numbering from here. Okay, you could have done it from here as well, right, in this way. Okay, now have a look. So what it's going to be? First of all, you'll be using the term cyclo. You'll be using the term cyclo. After writing cyclo, the main chain contains 5 carbon atoms. It's going to be pent, right? At carbon number 1, it's ene, right? At carbon number 1, it's ene. Either you write cyclopent-1-ene or you write just cyclopentene. One and the same thing. Okay. Now start the numbering over here. 1, 2, this is 3, this is 4, this is 5, this is 6. So it's going to be 1, 2, dimethyl. There are 2 methyl groups attached basically. 1, 2, dimethyl. It's going to be cyclo, hex. It's going to be cyclohex and 1-ene. This is the name of the compound. Perfecto. Look at the next one, my dear people. Look at the next one. Look at the next one. You have got 2 ways to do the numbering. You have got 2 ways exactly to do the numbering. If you do the numbering from here, 1, 2, 3, 4, then the locants are going to be 1 and 2. The locants are going to be 1 and 2. Perfect. Right? Now, if you do the numbering from here, just a second. If you start the numbering from here, it's going to be 1, 2, 3, 4. The locants are again going to be 1, 2. The locants are again going to be 1, 2. First locant is same. Sum rule is also coming out to be, the sum of the locants in both the cases is coming out to be same. Now you'll be using the alphabetical order. This is ethyl, this is methyl. Ethyl starts with E, methyl starts with M. So I'll be giving preference to ethyl. I'll be starting the numbering from here in clockwise direction, right? So what is going to be the numbering order? This is going to be 1, this is 2, this is 3, this is 4. So let me just quickly mention its name. So have a look. It's going to be at carbon number 1, it's ethyl. At carbon number 1, it's ethyl. At carbon number 2, it's methyl. 1 ethyl, 2 methyl. Then the parent chain is cyclic, right? The parent chain is cyclic. It's going to be cyclo. It's going to be cyclo. The parent chain contains 4 carbon atoms. It's going to be but, right? At carbon number 1, you have got a double bond. It's going to be 1. Then you write ENE. This is the name of the compound, right? I'm sure this is again clear to everyone. Right, people? Moving ahead. Let's try to name all them. Let's try to name all of these compounds again. In this particular case, there is nothing to worry. This is 1, 2, and 3. As simple as that. At carbon number 1 and carbon number 2, there are methyl groups attached. So it's going to be 1, 2, dimethyl. It's going to be 1, 2, dimethyl because this is the methyl group, this is the methyl group. 1, 2, dimethyl. Then it's a cyclic ring basically. It's cyclo, right? Cyclo, prop, 1-ene. Cycloprop 1-ene, right? As simple as that. Now look at the next one. This is again the simpler one. 1, 2, 3, 4, 5, 6, right? It's going to be cyclo, cyclohex. Cyclohex. Is it going to be hex or hexa? What do you think? It's going to be hexa, right? 1, 4. Diene, right? Perfect. And people, if you look at the last one, there are 2 ways you can do the numbering. If you select this as the parent chain, it's going to be 1, 2, 3, 4. But if you can select this as the parent chain, it's going to be 1, 2, 3, 4, 5, right? Now, which one are you going to select the parent chain? The one which contains more carbon atoms. This one contains more carbon atoms, right? So this one you are going to select the parent chain. So I got the parent chain, and in this particular one, the cyclic part, it's my substituent. Okay, so it's going to be at carbon number 2, there is cyclobutyl group attached. It's going to be 2 cyclobutyl. It's going to be 2 cyclobutyl. Then in the main chain there are 5 carbon atoms. It's going to be pentane, as simple as that. Yeah? Right, people? 2 cyclopentane it's going to be. Let's have a look on few more examples. Now we are going to talk about few more cyclic compounds only. Basically 2 rings are attached. 2 rings are attached, okay? 2 rings are attached. That ring which contains more carbon atoms, that's going to be my parent chain, right? So which ring among the 2 contains more carbon atoms? Have a look. 1, 2, 3, 4, 5, 6. At carbon number 2, it's cyclopropyl. Sorry, at carbon number 1, it's cyclopropyl. So it's going to be 1. Then I'll be writing cyclopropyl. I'll be writing 1 cyclopropyl. Then it's simple. It's going to be after that cyclohexane. This is the name. Yeah. Now look at the next one, mighty people. Look at the next one. Look at the next one. See, this side chain, it contains 1, 2, 3 carbon atoms. If this is the one, it contains 1, 2, 3, 4. Which one to select as the parent one? 3 carbon atoms, 4 carbon atoms. So this one is going to be a parent chain, right? This one is going to be a parent chain. And over here, as you can see, there is a complex substituent attached. And whenever you have the complex substituent attached, few minutes back only I've told you how to name it. Let's call this as carbon number 1. Let's call this as carbon number 2. So basically at this particular carbon, at carbon number 1, there is the complex substituent attached, right? And what is this complex substituent all about? In this complex substituent, at this carbon, you have got methyl. So it's going to be 1 methyl. It's going to be 1 methyl, 1, 2, 1 methyl ethyl, 1 methyl ethyl. Then you have got cyclobutane over here. This is cyclobutane. This is going to be the name of the compound. I'm sure it's clear. Right? I'm sure it's done and dusted. Let's move on and let's take few more cases, my dear people. So we are now going to talk about the Spiro compounds. What these Spiro compounds exactly are all about and how do we name them exactly. See, when 2 rings are attached at single common atom, when 2 rings are attached at single common atom, right? Such compounds are what we call as spirocyclic compounds. And this carbon, which is common to both the rings, it's called as spirocarbon. It's called as spirocarbon, right? So basically, whenever between 2 cyclic rings, there will be 1 atom which will be common, 1 carbon atom which is going to be common. So these compounds are what we call as spiro compounds. You have got a lot of spiro compounds basically, and let's see exactly how do we name these spiro compounds. Have a look, guys. Have a look. This is something which you are going to follow, and how you are going to follow this thing, have a look. I'll be directly taking the examples and let's try to name these compounds. Is first of all this the spiro compound, right? 2 rings are attached by means of a single carbon atom. 1 carbon atom is common to both the rings, so it is a spiro compound. 1 carbon atom is common to both the rings, it's a spiro compound. So both are exactly the spiro compounds, and spiro compounds, they follow a different nomenclature, right? So first thing, I will be writing Spiro. First thing, I'll be writing Spiro, right? After writing Spiro, I'll be using a square bracket. I'll be using a square bracket, okay? I'll be using a square bracket. Now I'll be selecting that ring. I'll be selecting that ring which contains minimum carbon atoms. I'll be selecting that ring which contains minimum carbon atoms, okay? So let me give the numbering first of all. I'll be starting the numbering from this ring because this ring contains the less carbon atoms. So let me start from here. I won't start from this bridged carbon. I won't start from this spiral carbon. I'll start from here or here. It's going to be 1, this is 2, let me call this as 3, this is 4, this is 5, this is 6, this is 7. So I've done the numbering, right? After doing the numbering, Spiro I've already mentioned. In the smaller ring, apart from this spiral carbon, apart from this bridged carbon, how many carbon atoms are there? 2. This is 2 I'm writing, comma. In this bigger ring, how many carbon atoms are there apart from this particular carbon? 1, 2, 3, 4. It's 2, 4, right? Then, in the parent chain, how many carbon atoms are there in total? 7. So you'll be writing simply hept, and everywhere there is a single bond, heptane. This is the name of the compound. Isn't it simple, my dear people? Look at the next one. You have got two rings attached, right? You have got two rings attached. Perfect. Now, which one is the smaller sized ring? Which one is the smaller sized ring? This is the smaller sized ring. So I'll start the numbering from here, right? I'll start numbering in this particular ring first. I'll start it from here. 1, 2, 3. This is 4. Let's call this as 5, 6, 7, 8. So this is the Spiro compound. I'll be writing Spiro first of all. After writing Spiro, let me use a square bracket. In this particular ring which contains lesser carbon atoms, apart from this carbon atom, how many other carbons are there? 1, 2, 3. So I'll be writing 3. And then in this bigger sized ring, how many carbon atoms are there apart from this rigid one? 1, 2, 3, 4. So 3, 4. Then in the main chain, there are 8 carbon atoms, so it's going to be simply oct. Everywhere is a single bond, so it's going to be octane. This is the name, right? This is the name. I'm sure it's done and dusted again. Let me take few more molecules, my dear people. These are few more molecules. Let's try to name them again. Let's try to name them, okay? So first thing, you guys know both the compounds are Spiro, so I'll be writing the Spiro first of all, then I'll be using the square brackets. I'll use the square brackets. Now I'll start the numbering. Numbering has to get started from that ring which contains lesser carbons. This ring contains lesser carbons, so I'll be starting numbering from here. 1, 2, 3, let me call this as 4, 5, 6, 7, 8, right? I've given the numbering, everything done. Now, in this particular ring which contains lesser carbons, apart from this carbon, how many other carbons are there? 1, 2, and 3. There are 3 carbons, so 3, comma. In this particular ring, how many other carbons are there apart from this particular carbon? 1, 2, 3, 4. 4 carbons, right? Then, in the main chain, there are 8 carbons, so you'll be writing oct, right? At carbon number 6, there is a double bond, so it's going to be 6, and then you're going to write ene. That's it. Perfect, that's it. Yeah, people? Heptane, not heptane, it's octane, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons are there basically. So it's octane. Octane basically, right? Not octane. If you look at the next one, my dear people, I'll be starting numbering from this particular ring because it contains lesser carbons. So 1, 2, 3, 4, right? Now, which should be the 5th carbon atom? This one or this one? This one is substituted. I'll be giving preference to this one. 5, this is 6, this is 7, this is 8. So what is going to be the name now? First thing, at carbon number 5 and at carbon number 6, there is dimethyl attached. There are 2 methyl groups attached. So it's going to be 5,6 dimethyl, right? That's done. Now it's a Spiro. It's a Spiro compound. I've mentioned Spiro. Then I'll be using square brackets. Square brackets have been used. In the low membered ring, 1, 2, 3. 3 carbons apart from the rigid one. In the higher membered ring, 1, 2, 3, 4. 3, 4, right? Then in the main chain, there are 8 carbon atoms. So it's going to be oct, right? And everywhere there is a single bond. So it's going to be octane. Perfect. Right, people? I'm sure this is again clear. So let me quickly move on to one more. These are few more examples. Let's try to name them. So both the rings are basically having same number of carbon atoms, right? But this particular ring, it's substituted, right? It has got substituents. Perfect. Let me start giving the numbering. Let me call this as 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Perfect. Now it's going to be 1, 2 dimethyl. At carbon number 1 and at carbon number 2, there are 2 methyl groups attached. So 1, 2 dimethyl, right? Since it's a Spiro compound, so I'll be writing Spiro. Use the square brackets. Apart from this particular one, 3 carbons, 3 carbons, right? So it's going to be 3, 3. It's going to be 3, 3, right? Then you have got total 7 carbon atoms. Is that? Yeah, 7 carbon atoms. So after this part, you will be writing heptane. Done and dusted. Look at this one. You have got 2 rings attached, joined by a single carbon, right? 2 rings joined by a single carbon, again a Spiro compound, right? Now do the numbering first of all from that ring which contains the lesser carbon. So this ring has the lesser carbons. So start the numbering from here. 1, 2, this is 3, this is 4, this is 5, right? This is going to be 6, 7, 8, 9, 10. So first thing, at carbon number 3, you have got methyl group attached. So it's going to be 3 methyl. It's going to be 3 methyl, right? Then I'll be using the term Spiro. Perfect, because it's a Spiro compound. I've used the term Spiro. Now I'll be using the square brackets, okay? In the low membered ring, 1, 2, 3, 4. 4 carbons apart from the rigid one. In the higher membered ring, 1, 2, 3, 4, 5. 5 carbons, so 4, 5, right? Then total, how many are there? Total there are 10 carbon atoms. So it's going to be dec, right? Dec, and at carbon number 3, there is a pi bond, there is a double bond, so it's going to be 3, then you are going to write ene. This is the name of the compound. Perfect, I'm sure this again done and dusted. Right, people? These are again 2 more compounds. Should I be giving you these 2 as the homework, or you guys are going to do it right? You want me to do it? Should I be giving these 2 as the homework, or you guys want me to do it? Let me know fast in the chats. Should I be giving these 2 as the homework? Let me know quickly. Okay, these 2 are basically your homework questions. So in the tonight's session, we have discussed the naming of alkenes, alkynes, cyclo, spiro, right? This one is dusted. In the next session, this IUPAC nomenclature will be done and dusted, right? If you follow the next session, I'm telling you, whatever molecule comes to you, you can easily name that molecule as per IUPAC. Perfect. Right now, I have not touched the functional groups. Functional groups will be touched in the next session. In the next session, we'll be talking about bicyclo compounds and then the molecules wherein there'll be different functional groups attached, right? Perfect, guys. At the end, one quick announcement for all of you. Well, there are majority of the students have already got into the NEET 2022 crash course. If some of you have not joined into the NEET crash course batch yet, do get enrolled as soon as possible in this particular batch, people, right? This batch has started on the actual Vedantu platform, wherein your whole syllabus in all the subjects gets covered before your NEET 2022 examination, right? In just 120 plus live sessions, right? Apart from that, you can ask unlimited doubts to your master teachers during the session. Whenever you face any sort of doubt, any sort of difficulty in understanding the concept, you can ask the doubt to your master teacher. No issues at all, right? And as I've told you, you need not to buy the test series from some other source. You will be getting the test series in this particular crash course batch only. No need to get the crash course from some other source. And this is the best designed crash course by the best teachers of Vedantu, my dear people, right? Who have got the teaching experience of more than 15-20 years of NEET. Perfect. Apart from that, there will be chapter-wise tests, right? By means of which you can compare your ranks with the other students who are sitting across the country. And at the same time, after every chapter is done, you'll be getting the summary notes, right? Key concepts, all these notes, simple short notes made by your master teachers in all the subjects, you'll be getting in this particular crash course batch, people. And these are the number of sessions which are allotted to different chapters. Your whole electrostatics will be done in just one session. The session is going to be 2.5 hours, right? Your master teachers will be starting exactly from the basics, and in just 2.5 hours, your whole chapter, theory plus problems, different whatever problem patterns will be there, every single thing will be done and dusted, right? So these are the number of sessions which are allotted to physics. Similarly, number of sessions which are allotted to chemistry, and similarly, number of sessions which are allotted to botany, right? And same for zoology. Perfect. So people, do get enrolled in this particular crash course batch which I'm talking about for the ones who have not enrolled yet. And these are going to be your teachers who will be training you. Rajni ma'am will be training you in biology, one of the best teachers of Vedantu. Ambika ma'am, again the biology master teacher, one of the best again. She'll be training you in this, right? Then you have got Disha ma'am, she'll be actually training you in chemistry, right? The Rahul sir, right? The alumni of IIT Kharagpur, he'll be training you in physics. So do get into this particular crash course batch as soon as possible, right? As soon as possible, because this crash course batch is the combination of everything. Your whole syllabus will be done and dusted before time, right? You will remain disciplined. You will get to know what to study, what not to study. All these things you can only know if you get enrolled in this particular crash course. And apart from that, people, apart from that, you will be getting the recordings. First, crash course will be there. You'll be getting the crash course, right? Apart from the crash course, you will be getting the recordings for entire class 11th course, right? Entire class 11th course recordings you'll be getting, right? You'll be getting access to the all class 11th recordings in different subjects, physics, chemistry, biology, maths, right? Whatever subject you want. All the recordings of class 11th will be provided to you, and you'll be getting the access of those recordings exactly for 1 year. Right? So for 1 complete year, you can watch the recordings. I mean, the ones who are planning to write the NEET in 2023, right? So do get enrolled in this, and this is completely affordable. After using this coupon code WSCC, you'll be getting this crash course only for 9K. So do get enrolled in it as soon as possible, my dear people. It's my personal suggestion for you guys to get enrolled in this particular batch. Then tell me after that, right? Because I've seen students getting, their ranks are shooted up after getting enrolled into the crash course batches which are started on actual Vedantu platform, right? Yes, so do get enrolled in it. So let me quickly show you how to get enrolled in this crash course. But before that, people, after every session, we share the PDFs of the sessions, right, on the Telegram group. And the link for the Telegram group is there in the description box of the video. Just click on the link, get added to the Telegram group, get all the notes in the form of PDF, and at the same time, you'll remain updated about the classes. So there is a link in the description box. I would want every one of you to get enrolled, to join that Telegram group in which we keep on updating you about the classes, about the session PDFs and every single thing. So finally, let me quickly show you how to get enrolled into the NEET 2022 crash course batch. This is the video which you guys are currently watching, right? Just drag it a little down, click on show more. After clicking on show more, there's a link for NEET 2022 crash course. Click on this particular link. Well, after clicking on it, just drag it a little down, click on buy now. After clicking on buy now, you need to put your number, email ID on which you get the OTP and everything, and eventually you get enrolled in the NEET 2022 crash course batch. Trust me, it is the best and the last option for you guys to shoot up your ranks, right? So do get enrolled. If you'll be having any sort of queries about the crash course, let me know in the comment section of this particular video, right? Or you can ping me personally on my Instagram. My personal suggestion and honest suggestion for you guys is to get enrolled in the crash course because your ranks will definitely shoot up. I've seen it in the last year as well. A lot of students, they improvised their ranks and currently they are into the government medical college, right? And I want the same for you as well. I want you to get the same government medical college. Absolutely. I want you to be in the topper range. Yeah. So you guys can again catch me up tonight on Vedantu J English channel. Tonight I'm going to do a session from the chapter Thermodynamics. I'll be solving around 30 to 40 questions from the chapter Thermodynamics, and your whole chapter will get revised properly in the form of questions, right? So do join me back tonight at 9:30, right after 15 minutes on Vedantu J English channel. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.